Okay, so we left off the last question just showing that elasticity in fact changes along a demand curve, and we left off with an explanation of why that's happening. The second big piece of what we want to learn out of this is how total revenue changes. So let's move on to question 2. And so from a demand curve, we can actually infer total revenue that would be earned by sellers in this coffee market, because we have the simple equation for total revenue. If we know what the price in a market is and we know what the quantity in a market is, you just multiply those two things to determine what the total revenue in the market is. So what I've reproduced here in this table is just the points that exist on this curve. So like 10, 0, quantity of 20, price of 9, etc. So this table is each one of those points. And so for any point on this curve, we could find total revenue by just multiplying those two values. So at a price of 10, what happened there? Price of 10 times a quantity of 0, our total revenue is going to be 0. Well, that should not come as a surprise. If we sell nothing, we're going to make nothing, even if the price is 10. Here, we have 9 times 20. And here we're making $180. And then we can continue on in this way. 8 times 40 is going to be 320. And then I'm just going to go ahead and fill the values in here. 420, 480. 5 times 100 is 500. 480, 420, 320, 180, and then 0. So again, like here, it shouldn't be a surprise that we make nothing. If we sell 200 things but we give them away for nothing, we're going to make no revenue. So this is just a chart of total revenue, and every demand curve has this theoretical possibility of revenue. And so let's think about these questions that are associated with this table. So question B is asking, let's just peek down there. As price increases, in what price range is total revenue increasing? So first of all, we want to say as price increases. Okay, so as price increases, let's make sure we're going in the right direction in this table. Price increasing means that we're going up this way. So as price increases, in what price range is total revenue increasing? Well, it looks like as we increase our price, we start at 0, and it looks like this range. This range right here is our increasing range. And the next one is, and then so we're asked to see, and then part C says, well, is demand elastic or inelastic in this region? So we're talking about the region where quantities are high and prices are low. Let's go back to the prior curve here. Well, quantities are high, prices are low. Well, we're in the inelastic region of this curve. So that's what we're looking for here. We're inelastic. Now here, as price increases, in what price range is total revenue decreasing? So like, we have this idea, like, this is great. We're raising our price, we're making more money, and then what starts to happen? When we get to here, we kind of have a maximum here, but then once we get to here, as we raise our price more and more, our revenue is in a decreasing range. So what's happening is, even though we're charging more per unit, our quantity is dropping off too quickly and we're losing money. And so that's what's going on here. So price ranges, so total 0 to 5 is where revenue is increasing. 5 to 10 is where revenue is decreasing. And then we're asked, is demand elastic or inelastic in this region? Well, let's think about that again. We're in the decreasing range is in the spot where prices are high on the higher end and quantities are low. Let's go back to our graph here. Prices are high, quantities are low. Well, hey, that's the elastic region of the demand curve here. And so we have the answer to that question. Elastic. So it's not a coincidence, actually, that inelastic regions are creating revenue increases for us. Elastic regions are creating revenue decreases for us. When you think about the smoker example, if demand is inelastic, I can raise my price and make more money because demand's not going to drop off. But if I'm in an elastic region of a curve, I raise my price, demand's going to fall much more, and so I'm going to lose total revenue. And so this supports our intuition about what these things mean. Let's go ahead and finish this up. At what price quantity combination does total revenue reach a maximum? Well, that was right at price equals 5. Price equals 5. Quantity equals 100. That was at the midpoint. And then based on that prior problem, I had told you that, I guess you didn't know for sure, but it turns out that the elasticity, in fact, is 1 at this revenue maximizing point. And so that's kind of a general idea here, is that if elasticity is 1, our revenue will kind of always be at a maximum there. Well, I'm going to assume here that you're all mathematically inclined, and I'm asking you what shape would this total revenue curve have if you plotted it. If we go back to the points, it looks like it kind of starts at 0, goes up for a while, hits a maximum, and comes back down. Well, those of you who've had me before know that I love spreadsheets, so I actually went and put this problem into a spreadsheet here. And so all I've done is typed in the prices and quantities, and then, interestingly, I've actually computed the elasticity using all these different points, and you can see I had asked you to compute 19, 1.2, and 0.2, but you can see if I did them for all the different points on this curve, here's how the elasticity moves. It starts really elastic, crosses over, and then becomes inelastic as the quantity goes up. Total revenue is just multiply P times Q. These in column I here. That's just what's in your chart. If I just graph quantity and total revenue, this is what I get off to the side here. So 0 goes up to 500 at a quantity of 100, and you should recognize that as a parabola. You don't really need to know that. I just put it in there because I thought it was kind of interesting, and a lot of times total revenue curves do have this kind of shape, that there's a maximum that occurs in Okay, so let's flip back to our chart here, or sorry, our notes. And so yeah, that shape is just gonna be a parabola. Like I was just saying, sorry, the phone rang there. That parabola shape is very common for total revenue. Where if you charge too much, your revenue goes away. If you charge too little, you make nothing. And then there's some point, kind of there's a sweet spot in the middle there where your revenue gets the highest, and you can change your price. And that turns out that sweet spot, like I said above, is going to be where the elasticity equals 1. And so managers of companies are always in a constant trying to find that revenue maximizing spot, because even though this is a nice theoretical idea, but there's not like a sign out somewhere that says, oh, by the way, elasticity equals 1 here, so just go ahead and set your price. A lot of times you have to test different prices and quantities and kind of see what happens. And so elasticity, even though it's a nice concept, they're in fact a little bit hard to measure with precision. So on I, let's think about again this total revenue. So again, total revenue equals price times quantity. And we saw that it changes along this curve for 2 different reasons. Price and quantity are both part of it. And so if I raise my price, my quantity goes down. So the question is, which one wins? I don't know. If I lower my price and raise my quantity, it depends, again, which one wins. And so it turns out that elasticity is the clue that's going to show us how that works. So I guess for this question, I'm just asking you to see that, notice that for any time we're thinking about total revenue, we have to worry about these 2 different impacts, the price impact and the quantity impact, and they do, in fact, move in opposite directions. And it is always true because of the law of demand. Right? We know that when you increase price, quantity goes down. When price goes up, when price goes down, quantity goes up, price goes up, quantity goes down. So it is, in fact, always true. And then the wrap-up question here is, why does elasticity give us the clue, or to see what's going to happen with total revenue? Let's go ahead and think about an example here. If I have total revenue equals price times quantity, and let's just throw out an elasticity of 2. I claim that knowing simply that elasticity will tell me which way total revenue will go if I increase or decrease my price. Let's think about why. We know elasticity is going to equal percent change in Q over percent change in P. If I know this number is 2, I know that my percent change in quantity is going to be 2 times my percent change in price. So let's think about this, or actually I'm going to write this a different way also because I think it'll be more helpful. My percent change in price is going to be my percent change in quantity divided by 2. Well, it turns out I wrote this the other way, but I'm going to go ahead and actually use this one here for the way I want to think about it. So let's think about a price change. I don't know, 10% increase in price. So my price goes up 10%. Well, my elasticity of 2 tells me that my percent change in quantity is going to go down 20%. It has to go down, and because of elasticity, I know it's going to go down 20%. Well, what's going to happen when prices go up 10 but quantity goes down 20? My total revenue has to fall. My quantity fell more than my price change went up, and so my total revenue falls if elasticity is equal to 2 and I do a price increase. Now if I did a price decrease from this point, let's think about what happens. Total revenue again is P times Q. If I decrease my price, say 10%, my quantity, percent change in price is 10. I think about my elasticity here. My quantity in this case will go up 20%. And now what's going to happen to my total revenue? Total revenue will actually increase because my prices fell by 10%, but I made up for it in volume because I sold 20% more. So my total revenue has to increase in this case when elasticity equals 2 and I drop my price. So this makes sense. If I know I'm in an elastic region of the demand curve and my objective is just to maximize revenue, what should I do? I should drop my price, because if I drop my price, I'll make more revenue. And consequently, I shouldn't increase it, because if I increase it, I'll just keep losing more money. And so this is the way you can think about any of these problems when I ask you about which way total revenue is going to change. It's all based on elasticity, and it all comes back down to this total revenue decomposition of price and quantity. So when we think about this, we're going to think about the price effect and the quantity effect. And both of these are important. And in this question here, when I say which one wins, the reason we don't, in the prior question, I asked, here, which one wins? Price effect, quantity effect. Well, the only way you know that is if you know the elasticity, and you just can reason through it this way to declare a winner. So if the price effect is bigger than the quantity effect, and I raise prices, then that's a good thing. If the quantity effect is bigger than price effect, then I want to lower my prices, as shown in this example. So again, just to recap and summarize, like the idea here is what I want you to be able to do is understand how and predict how total revenue changes when price changes, and using the elasticity to do that.